Hello everyone. In this tutorial we are going to go over sets in Python. Sets are unordered collections of unique elements and pay special attention to the word unique. So for example, if you have a set with more than one of the same type of item, the extras of that item will be removed. So sets would be a collection you might want to work with when you only want to deal with unique items. To create a set, you can use the curly brackets here, or you can use the word set in parentheses with the square brackets. For most of our examples, we'll be using the curly brackets. We have a whole bunch of examples to get through on all the cool stuff you can do with sets, so let's get started. So here we have an example set labeled set1 with 5 items. Now if you want to know the count of the number of items in your set, you can use the len function. So here we can clearly see that we have 5 items in our set. However, if there are more items than you want to count, just use the len. Let's select this and run it, and you can see we get back 5. Next, to test for membership, you can use in. So here we have set 2 with 2 items, blue and green. And to test for membership in that set, simply state the name, use in, and then the set name. So here we're testing for membership of blue in set 2. We can see blue is in set 2, so this should return true. Select this and run it, and we get back true. To test for non-membership, use a similar setup. However, instead of in, you use not in. So in this case, we have set 3 with 2 colors, purple and orange, and we can test for non-membership by choosing another color. For example, we'll say yellow not in set 3. We can see that yellow is not in set 3, so this should return true. Okay, and we get back true. Next, to see if a set is a subset of another set, you create your 2 sets, and in this case we've created another variable, and we have assigned the code that will tell us if set 4 is a subset of set 5. Now, we can see in set 4 we have techno and jazz, and set 5 also has techno and jazz and another element, so set 4 should be a subset of set 5. So let's select our code and run it, and we should get back true, and we do. Next, to test if a set is a superset, you can use the Is Superset, and you can see in set 6 we have reggae music, and in set 7 we have reggae music and blues. Set 7 has everything that set 6 has in it, and an extra element, so set 7 should be considered a superset of set 6. Let's go ahead and run this, and this should return true, and we get back true. Next, let's show the test for Is Disjoint, and the Is Disjoint returns true if the sets have no elements in common. So here we have set 8 and 9. In set 8 we have 3 types of trees, maple, oak, and cedar, and in set 9 we have another 3 types of trees, but they're completely different, willow, redwood, and pine. So you can see there are no elements in common, so let's select this and run it, and we should get back true. And we do. Now if we were to change this, let's say we put maple in set 9, now there is one element in common at least. Let's select this now and run it and see what we get. And now we get back false. And that's because there's maple in set 8 and in set 9, so there's at least one element in common. For the next example, we're going to use the union, which you can just think of as joining 2 sets together. So here we have set 10 with bronze and silver and set 11 gold and platinum. We've set up a new variable, variable 7, and we have used the union to join set 10 and 11. So when we select this and run it, we should get all 4 together, and we do: gold, bronze, platinum, silver. For our next example, let's go over the intersection. So here we have sets 12 and 13. In set 12 we have tiger and lion. In set 13 we have tiger, lion, cheetah, jaguar, lynx. And with the smaller sets you can usually see what's going on. However, when you have larger sets, it's very useful to be able to use these types of functionality to tell you exactly what's going on. But we can see that tiger and lion are in common here. That would be the intersection. So let's go ahead and select this code and run it, and we should get back tiger and lion. And we do. Okay. Now the next 2 examples have to do with a difference. And for the first difference example, this will create a new set with elements in one but not in the other. So in set 14 we have elements A, B, and C, and in set 15 we have elements A, B, and D. So you can see that what is in common is A and B, but set 14 has C, which is not in 15, and set 15 has D, which is not in 14. So let's go ahead and select this and run it. And you can see that because of the way we've set this up, we said set 14 dot difference set 15, which means this is going to tell you what's in 14 but not in 15, and that would be C. Okay, now the next difference, which is the symmetric difference, is slightly different. So here we have sets 16 and 17, which are the same as what we had in sets 14 and 15. So we have A, B, and C in set 16, and A, B, and D in set 17. So again, what's in common is A and B. Set 16 has C, which is not in 17, and set 17 has D, which is not in 16. Now when we select this and run it, what you're going to see is, whereas in this example here with sets 14 and 15, we wanted to know what was in set 14 but not in 15, and it gave us back C. The symmetric difference will create a new set with elements in either but not both. So when we run this, we should get back C and D. And we do. Moving on. To create a copy of a set, you can simply use this syntax here with the copy function. Next, to add an element to a set, create your set, state the name of the set, use a dot to access the add, and then put your new set element in the parens. So to start, in our set 18, we have two types of dogs, a Doberman and a Boxer. We used add to add another type of dog, a German Shepherd. So now when we select this and run it, we should have all three dogs in one set, Doberman, Boxer, German Shepherd. Let's go ahead and run it. And we get all three dogs in one set. Now if you want to add several elements to a set, you can use the update. So you create your set, then state the name of the set, use a dot to access update, and then put your new set elements in the curly brackets. So in set 19, originally we had 3 elements, 1, 2, and 3. We've updated set 19 with elements 4, 5, and 6. So when we select this and run it, we should have a new set with elements 1, 2, 3, 4, 5, and 6. And that's what we get. We're good to go. Next, to remove an element from a set, you can simply create your set, state the name of the set, use a dot to access remove, and then state the name of the element you want to remove. So to start, in set 20, we had elements A, B, and C. We have now removed element C. Let's select this and run it. And now set 20 should only have elements A and B. Okay? And finally, for our last example, this is just an example using the other type of syntax to create sets where you use the set word, and then in parens, you put your set elements in square brackets. And also notice, as we mentioned in the beginning, that here we have a set with 3 A's and a B, and sets are unordered collections of unique elements, so only one A will remain in this set. So let's go ahead and select this and run it. And you can see in this set with 3 A's and 1 B, the duplicates are removed and we get a set of just A and B. Okay, so that's it for this tutorial on sets in Python. We will be doing many more Python tutorials in the near future. Join us for those and we'll see you next time.